Now, how do we find the asymptote for hyperbola? First off, you change to this form already. After you change to this form, right? Okay, this is hyperbola because it's of different sign. If x squared and y squared, the coefficients are of different sign, confirm is hyperbola. Please know that. All right. So once you get that already, what you need to do is just equate these two to give you your these two here, this one, and to give you asymptote. Then the rationale is y. So as x goes to infinity, okay, basically the equation asymptote is x minus 1 square 2 equals to y plus 2 square. Okay. Then the question is, how come this would be my asymptote? Okay, I will explain to you. Now, how do you see this equation? This equation is quite okay. What you see is basically very simple. The difference between these two entities here is always 1. It's always 1. Okay. So it's like super huge value. So when x goes to infinity, right? Okay, let's say if you have $1 billion in the bank, lah. Okay. The first question I have for you, why are you attending math tuition? $1 billion. You shouldn't be here, man. Yeah. But billion, do you know that? Yeah. Yeah. So you $1 billion, right? Like billionaires, if you have that amount of money, right? Usually billionaires do not know how to calculate their own money. You know, it's like so much money they can't really calculate. Then they just wait for people to estimate their wealth. That's how filthy rich they are. Okay. So there's the same concept. If x goes to infinity, let's say you $1 billion, you go and withdraw $1 out from your bank, right? Next day, the news outlet won't say you are no longer a billionaire. You get what I'm saying? Because that $1 is so insignificant as compared to the 999,999,999. So essentially, if this goes to infinity, you can be sure that this will also, okay, if this goes to infinity, this entire thing goes to infinity, this will also go to infinity. Okay? And they will equal to each other because the difference is 1. Okay, that's how you get the asymptote there. So that's how you understand it. This entity here goes to infinity. Since the difference is 1, therefore this guy would be roughly equal to each other. Okay, so this is the equation asymptote. Y is equal to plus minus x minus 1 square root 2 minus 2. Easy game. Open square root lah. Okay. Just do it slowly. But I think this one you all should be able to do it already, because you guys are prepared. Go. Okay, so this is the equation. Now, then stating equation asymptote at the intersection point. I think the main thing of drawing hyperbola, if you're not sure how it look like, right, just key in calculator, make y the subject, key in calculator. So here, you make y the subject as such. It will be 1 minus x minus 1 square over 2. This will be y equals to minus 2 plus minus 1 minus x minus 1 square. You just key in calculator. The graph, your calculator will give you the best shape, like will give you just straight up give you the hyperbola. So hyperbola is either top down or left bottom. Okay. So we have the equation asymptote ready. Now what we need is to find the graph. So this graph here, I'll just key this in. So -2. Just practice keying calculator lah. If you don't, just use this time. If you can't do it, let me know. I will help you out. Then this is square root 1 minus alpha x minus 1 square for 2 in calculator. This will be your, how come? Minus. I just embarrassed myself, sorry. This is plus. Yeah. So this is wrong. So this is -1. This is plus. Then this is your hyperbola. You get it? This is hyperbola. This is as good as it gets really. So then you just go to window and then so zoom box. Usually I'll say is just get rid of the underutilized space above and below. Then I'll just gonna zoom box here. Okay. Then I'm just gonna draw this out. There you go. Then I'm gonna key in my equation of my asymptote. So -2 plus square root. Always key in the equation asymptote because you want to see whether your equations are correct or not. So this is x minus 1 over root 2. Graph it. Okay. Graph it, you get the graph there. Then this will be the center, the midpoint here. You copy this. This is your perfect hyperbola shape. Okay, so just copy this down. So you get the perfect graph here. Of course, label the asymptotes. They usually will ask you to label the asymptotes. Then the center here, needless to say, center is 1, -2. This guy here, this is it's just like the ellipse. The vertical stretch here is the P. So this is square root 2 square. Root 2. So if you want to know what is this sort of turning point here, 1 plus root 2 comma minus 2, 1 minus root 2 comma minus 2. There you go. Then once you're done with that, you go to your GC, find what is the 0. Go up. Enter. Enter. Negative 2.16. Then the other side, you can also just find the 0 lah. Left bound, right bound. 4.16. Comma 0. Okay, there you go. That is y and this is x. Good job, Mr. Gan. I think then we can do the next part. Need to label the asymptotes. So y equals to minus 2 plus root. You can just leave it like that lah. You don't really need to expand it. Just leave it like that. Okay? It's okay to leave it like that. This part here, guys. This one here, what is this? This is a line equation. Okay, so what I'll suggest is a lesser known line equation is this form here, guys. This one. This is a lesser, because we don't really teach you in secondary school this form here, right? M is a variable. M is a gradient. So meaning whichever point, the point, if you move that to the other side, you know that this is a line equation with gradient. Gradient what? M, right? And passes through what? When this is 0 and this is 0 lah. Okay? So because one point I know for sure, I know M is ever changing. I know that M is always changing, right? But if M multiplied by 0, I can be sure that this is also 0. So in other words, it will pass through 1 comma minus 2. Understand? 1 minus, which is here lah. Okay? So what you need to visualize is actually a line which pivots about this point here. The gradient. So it just pivots about there. So essentially, right, if you look at on Desmos, right, the graph that you're looking at is y. Like that. Like that. So it pivots about here. Okay. So you think about it, this is how it pivots. With different value of M, it just pivots like that. Okay. So the question now is, we want it to does not intersect C. So we want it to be like that. Yeah, change M to small m lah, because it looks very ugly, right? Okay. We want it to be here, but we do not want it to cut here. Okay, and we want it to be here. Understand? So anything, so remember, anything steeper. Okay, this is the equality line. So this gradient is how much? This gradient here is this asymptote here, gradient is root 2, right? Anything steeper than this is m bigger than 1 over root 2, right? Anything steeper. Okay. Anything less steep will be m less than 1 over root 2. Similarly, for this guy here, this is m equals to negative 1 over root 2. Anything less steep than this is m less than, actually steeper. This is anything steeper. This is actually steeper. Less than root 2. Anything here, anything clockwise is less than. Anything anti-clockwise is more than. Okay. So what you want is essentially this guy here and this guy here. Can you equal to this gradient here? Can. You can you can equal to this gradient because the line don't intersect the curve when at the asymptote. So this case here, from graph line through point 1 minus 2 with gradient m cuts C. They want what? Doesn't cut C. When m is at least at most 1 root 2.